Now we take up the next question. Here fx is given to be this much, and we have to find the intervals of increase and decrease of this function in 0 to pi by 2. So what we do is we find the derivative of this function. It is 4 sine cube x into differential of sine x is cos x, plus differential of this 4 cos cube x into differential of cos is minus sine x, and this is equal to 4 sine x cos x is common. 4 sine x cos x is common, and we are left with sine square x. From here we will get sine square x, because sine x and cos x are common. So we are left with sine square x. From this bracket we will get minus cos square x. Now, are there any positive definite terms? Yes, these are positive definite in 0 to pi by 2. In first quadrant all the t ratios are positive. So we can leave this and put sine square x minus cos square x equal to 0, because sine x and cos x are positive in 0 to pi by 2. So these are positive, they do not change their sign in this interval. So we can leave them and put this equal to 0. That is sine square x is equal to cos square x, or tangent square x is equal to 1. This implies tangent x is equal to plus minus 1, and this implies tangent of x is equal to 1, because x lies in first quadrant. 0 to pi by 2 in first quadrant, tangent x is always positive, so negative sign is rejected. So we have tangent x is equal to 1, and this implies x is equal to pi by 4, because we have to consider the values of x lying in only first quadrant. So we take x equal to pi by 4. Now we break this interval 0 to pi by 2, and this is pi by 4. So we break this interval into 0 to pi by 4, pi by 4 to pi by 2. So we make the following table. First column is interval, sine of f dash x, and conclusion. First interval is 0 to pi by 4, and second interval is pi by 4 to pi by 2. Now in 0 to pi by 4, in 0 to pi by 4 we have to find this sine of f dash x. In this interval take any point, say pi by 6, that is 30 degrees. Sine of, no, this is positive, and sine of 30 is 1 by 2. So we will have 4 into positive into sine square 30. Sine square 30. Sine 30 is 1 by 2. So this will be 1 by 4 minus. And cos of 30 degrees. Cos of 30 degrees is root 3 by 2. So root 3 by 2 whole square is 3 by 4. So we have positive, and this will be negative. So total sign is negative. So f dash x is negative in this interval. This is positive in first quadrant, this is positive in first quadrant, and sine square x is 1 by 2, 1 by 2 square is 1 by 4, and this is root 3 by 2, root 3 by 2 square is 3 by 4. So this is plus into minus. So this is negative. And for the second pi by 4 to pi by 2, take any point in this interval. Say pi by 3, that is 60 degrees. Now this will be 4 into first quadrant sine is positive, in first quadrant cos is positive, and this will be now sine of 60 degrees. Sine of 60 degrees root 3 by 2. Its square will be 3 by 4. And cos of 60 degrees is 1 by 2. So 1 by 2 square is 1 by 4. So this is plus, and this will also be positive. 2 by 4 positive. So plus into plus into plus is positive. So this will be positive. So we can now draw the conclusion. Therefore, f dash x is negative. Therefore, fx is monotonically decreasing. F dash x is positive. Therefore, fx is monotonically increasing in this interval. In fact, fx is strictly monotonically decreasing in this interval because this is less than 0. This is strictly greater than 0. Therefore, fx is strictly monotonically increasing in this interval. So we can draw the conclusion fx is monotonically increasing in pi by 4 to pi by 2, and fx is monotonically decreasing in 0 to pi by 4. And since fx is a continuous function in 0 to pi by 2, therefore we can include the endpoints. Therefore, fx is monotonically increasing in closed interval pi by 4 to pi by 2, and fx is monotonically decreasing in closed interval 0 to pi by 4. Now if in above question we have x belongs to minus pi by 2 to pi by 2 instead of 0 to pi by 2, then how will we proceed in this question? Now f dash x from 1 is 4 sin x cos x into sin square x minus cos square x. Now in first and fourth quadrant, this is minus pi by 2, this is 0, this is pi by 2. So these two quadrants are given. So in this quadrant cos x is positive, and in this quadrant also cos x is positive, and therefore cos x is positive, definite in minus pi by 2 to pi by 2, and therefore we put 4 sin x into sin square x minus cos square x is equal to 0, and therefore we get sin of x is equal to 0 and sin square x minus cos square x is equal to 0, and therefore sin x is 0, and this implies x is equal to 0. In this quadrant, in these two quadrants, sin x is 0 only on the horizontal line, so at x equal to 0 and pi, but pi is not in this interval, so we take only x equal to 0, and in this we have sin square x is equal to cos square x, that is tan square x is equal to 1. Therefore, tangent x is equal to plus minus 1. Tangent x is equal to 1 implies x is equal to pi by 4, because tangent is positive in first quadrant. So we must take the value from the first quadrant, and in first quadrant tangent x is 1 at pi by 4. And tangent of x is equal to minus 1. Tangent is negative in fourth quadrant. So we must take a value from the fourth quadrant. That is x is equal to minus pi by 4. And so we break this number line into, this is minus pi by 2. This is pi by 2. And this is the point x equal to 0. And this is pi by 4, and minus pi by 4 will be somewhere here. So we must break minus pi by 2 to pi by 2 into these intervals. Minus pi by 2 to minus pi by 4, minus pi by 4 to 0, 0 to pi by 4, and pi by 4 to pi by 2. So we make the following table. Minus pi by 2 to minus pi by 4, minus pi by 4 to 0, and 0 to pi by 4, and last is pi by 4 to pi by 2. Now we have to find sine of f dash x in all these intervals. Sine of f dash x will remain same throughout this interval. It will remain same in this interval, and this and this. So instead of finding the sine of f dash x in whole of this interval, I will take only one point in this interval and find the sine at that point. Now in minus pi by 2 to minus pi by 4, that is minus 45 to minus 90. Take any point. That is minus 60. Minus 60. Therefore, at x is equal to minus 60 minus pi by 3, f of minus pi by 3 will be 4 into sine of minus pi by 3. That is in fourth quadrant. In fourth quadrant, sine is negative. This is 4 into negative into cos of x in fourth quadrant is positive. So this will be plus. And we will have sine square minus pi by 3. Sine of minus theta is minus sine theta. So sine of minus pi by 4 will be minus sine pi by 3. So sine of minus pi by 3 will be minus sine pi by 3. And we have whole square, so we will have sine square pi by 3. And sine of pi by 3. Sine of pi by 3 is sine of 60 degrees. We will have sine square pi by 3 minus cos square minus pi by 3. Cos of minus theta is cos of theta. So we will have cos square pi by 3. We will have cos square pi by 3. So this is equal to, this is negative, and this will be sine square pi by 3. Sine of 60. Sine of 60 is root 3 by 2. So root 3 by 2 whole square is 3 by 4. Minus cos 60. Cos 60 is 1 by 2. So 1 by 2 square is 1 by 4. So we will have, this is negative, this is positive. So overall sine will be negative. F dash x will be negative. And in this interval, minus pi by 4 to 0, take any point. Minus 45 to 0, minus 30, that is minus pi by 6. At minus pi by 6, we will have f of minus pi by 6. This will be equal to 4. In fourth quadrant, this is negative, this is positive. We will have minus, and this will be plus. We need not find the values. And sine square minus pi by 6. Sine of minus pi by 6 is minus sine pi by 6, and minus square is plus. So we will have sine square pi by 6 minus cos square minus pi by 6. Cos of minus theta is cos theta. So we will have cos square pi by 6. So this is equal to negative into sine square pi by 6. Sine of 30. Sine of 30 is half. So half square is 1 by 4. And cos of 30 degrees is root 3 by 2. Root 3 by 2 whole square is 3 by 4. So we will have, this is negative and this is again negative. Minus 2 by 4. So negative negative is positive. So we will have a positive sign. And since this function is continuous, we will have alternate negative and positive sign. So this sign will come out to be negative and this sign will come out to be positive. I just verify this. In 0 to pi by 4, any point is 30 degrees, that is pi by 6. So this will be equal to 4 sine pi by 6. In first quadrant, sine is positive. In first quadrant, cos is also positive. And we will have sine square pi by 6. Sine of pi by 6. Sine of pi by 6 is sine 30. Sine 30 is 1 by 2. So we will have 1 by 4. 1 by 2 whole square. Minus cos of pi by 6. Cos pi by 6 is root 3 by 2. So root 3 by 2 whole square is 3 by 4. So we will have, this is equal to positive, positive, and this is negative. Positive into negative. So we will have negative sign. F of pi by 6 is negative. So in this quadrant, sign will be negative. I have already written it. And f of now pi by 4 to pi by 2. So 45 to 90. Take any point. 60 degrees. 60 degrees is pi by 3. So this is f pi by 3. This is equal to 4 into, in first quadrant, sine is positive. In first quadrant, cos is also positive. And we have sine square pi by 3. Sine square pi by 3 minus cos square pi by 3. So this is equal to positive into sine square pi by 3. Sine of 60. Sine of 60 is root 3 by 2. Root 3 by 2 whole square is 3 by 4. Minus cos square pi by 3. Cos pi by 3 is half. Half square is 1 by 4. So we have a positive sign. This is positive, this is positive. So we will have positive sign. So in continuous function, we have negative, positive, negative, positive. Alternate negative and positive sign. Now we draw out the conclusion. Now in this interval, f dash x is negative. Therefore, fx is monotonically decreasing. In this interval, fx is positive. Therefore, fx is monotonically increasing. In this interval, it is negative. So fx is monotonically decreasing. In this it is positive, therefore fx is monotonically increasing. Therefore fx is monotonically decreasing in minus pi by 2 to minus pi by 4 union 0 to pi by 4. And fx is monotonically increasing in minus pi by 4 to 0 union pi by 4 to pi by 2. And since fx is a continuous function in minus pi by 2 to pi by 2. In fact, this function is continuous everywhere. So we have fx is monotonically decreasing in, we can include these endpoints in minus pi by 2 to minus pi by 4, union 0 to pi by 4, and fx is monotonically increasing in minus pi by 4 to 0 closed interval, union pi by 4 to pi by 2. We can include these endpoints and change these brackets into square brackets. So if we have an interval minus pi by 2 to pi by 2 instead of 0 to pi by 2, we will solve the question like. Now we take up the next question. In this question we are given fx is equal to this much, and we have to find the intervals of increase and decrease of this function. So first we find f dash x. F dash x, this is equal to, denominator is 2 plus cos x whole square, gx whole square, gx is 2 plus cos x into differentiation of fx, that is f dash x, gx square, gx into f dash x. So differentiation of this will be 4 cos x minus 2 minus first function differentiation of second plus second function into differentiation of first. So this is the differentiation of this function. Now we have gx square, gx into f dash x minus fx into g dash x. Fx is 4 sine x minus 2x minus x cos x into g dash x. Differentiation of this is 0 and differentiation of this is minus sine x, and this is equal to, now we simplify this bracket. We have 2 plus cos x into 4 cos x, and this is minus cos x. This is a bracket here, so minus minus plus, and this will be minus. So we have 3 cos x. I have taken this term and this term, minus 2 and minus minus plus x sine x. So we have simplified this bracket and we have this. Now this is minus minus plus, so plus 4 sine square x, 4 sine square x minus 2x sine x, 2x sine x minus x sine x cos x. This into this, minus x cos x sine x, minus x cos x sine x, whole divided by 2 plus cos x whole square, and this is equal to, now further simplify this, we will have, open this bracket, we will have 6 cos x, 6 cos x minus 4 plus 2x sine x. Now multiply by cos x, so we have plus 3 cos square x minus 2 cos x plus x sine x into cos x. Now this term plus 4 sine square x minus 2x sine x minus x sine x cos x. Now this term cancels with this, and this term cancels with this. The denominator is 2 plus cos x whole square, and this is equal to 6 cos x minus 2 cos x. This is 4 cos x. This and this minus 4 plus 3 cos square x, and this is plus 4 sine square x. One term from this bracket. This divided by 2 plus cos x whole square. So this is equal to 4 cos x minus 4 plus 3 common, we have cos square x plus, I write this as 3 sine square x plus sine square x. So 3 is common, we will have cos square x plus sine square x plus sine square x. This I have written 3 sine square x plus sine square x whole divided by 2 plus cos x whole square, and this is equal to 4 cos x minus 4 plus, this will be 3 plus sine square x whole divided by 2 plus cos x whole square. This is equal to 4 cos x minus 4 plus 3 is minus 1 plus sine square x, 2 plus cos x whole square. Now 1 minus sine square is cos square, so this will be minus cos square x, minus I take common, 1 minus sine square, so this will be minus cos square x. So this is equal to 4 cos x minus cos square x whole divided by 2 plus cos x whole square, and this can be written as cos x is common and 4 minus cos x whole divided by 2 plus cos x whole square. Now I copy down this term on the next page and solve the question. Now this is equal to 4 minus cos x over 2 plus cos x whole square into cos of x. Now this is positive definite. Why? Because minus 1 is less than equal to cos x is less than equal to 1. Cos lies between minus 1 and 1. So 4 minus cos x will be positive. So this is a positive definite term. 4 minus cos x over 2 plus cos x whole square is positive. And therefore put cos x equal to 0, and therefore x is equal to, now we will solve this question in 0 to 2 pi. So cos x is 0 on the vertical line, that is pi by 2, 2 pi by 2, 3 pi by 2, at pi by 2 and 3 pi by 2. This is pi by 2 and 3 pi by 2. We can break this interval 0 to 2 pi into, this is pi by 2, and this is 3 pi by 2. So this can be broken into 0 to pi by 2, pi by 2 to 3 pi by 2, and 3 pi by 2 to 2 pi. We make the following table. Now in first column we have interval, second sign of f dash x, and in third we have conclusions. So first interval is 0 to pi by 2, and second interval is pi by 2 to 3 pi by 2, and third is 3 pi by 2 to 2 pi. In 0 to pi by 2, this is positive definite. So f dash x, sign of f dash x will depend only on cos x. So we need only check the sign of cos x. So in 0 to pi by 2, in first quadrant, cos is positive. So this will be positive. In pi by 2 to 3 pi by 2. In pi by 2 to 3 pi. In second, cos is negative. In third, cos is negative. So in this interval, it is negative. And in 3 pi by 2 to 2 pi, fourth quadrant, cos is positive. This is positive definite, so this will remain always positive. So while finding the sign of f dash x, we will find the sign of only cos x. So these are the signs of f dash x. Conclusion: fx is monotonically increasing. Negative: fx is monotonically decreasing. And if this is positive, therefore fx is monotonically increasing. Therefore we can write fx is monotonically increasing in 0 to pi by 2 union 3 pi by 2 to 2 pi, and fx is monotonically decreasing in pi by 2 to 3 pi by 2. And since fx is a continuous function, and therefore fx is monotonically increasing in 0 to pi by 2 union 3 pi by 2 to 2 pi, and fx is monotonically decreasing in pi by 2 to 3 pi by 2. Now we take up the next question. In first part we are given fx is equal to log x by x, and we have to find the intervals of increase and decrease of this function. Now first we have not been given any interval, so we must find the domain of this function. Domain of f is equal to, now domain of log x is 0 to infinity open interval, and x must not be equal to 0, but x is already not equal to 0 in the domain of log x. This is the domain of log x, and x equal to 0 has already been excluded. So this is the domain of this function. Now we have to find the intervals of increase and decrease of this function in this domain. First we find f dash x. F dash x is equal to gx square gx into differentiation of fx, that is gx square gx f dash x. F dash x is 1 by x minus fx, that is log x, into differentiation of gx, that is 1. So we have 1 minus log x whole divided by x square. There is only one positive definite term, that is x square. So sign does not depend upon 1 by x square, and we are left with 1 minus log x. So put 1 minus log x equal to 0. So log of x is equal to 1 is equal to log of e. Therefore, x is equal to e. So we must break this interval into two, 0 to e and e to infinity. We must break this interval 0 to infinity. We must break this at the point e, 0 to e and e to infinity. We make the following table. First column is interval. Second is sine of f dash x, and in third column we enter conclusion. Now first interval is 0 to e and second is e to infinity. If in any question there is a point at which the function is not defined and it is in the domain of the function, then we must also consider that point while breaking the line. All those points at which this is 0, and also consider the points where it is undefined. Here it is undefined at x equal to 0, but x equal to 0 is not in the domain. So I am not considering x equal to 0. But if the point is in the domain, then you must consider 1 minus log x equal to 0, and this point x equal to 0 must also be considered. So we get 0 to e. Now if we have this function, say fx is equal to log of x, then f dash x is 1 by x, and therefore f dash x is greater than 0 for all x greater than 0. Therefore log of x is monotonically increasing function. Its value will go, as x increases, its values will go on increasing. Log x is monotonically increasing. So as x increases, its value will also increase. Therefore, for this interval, x less than e, 0 to e, that is x less than e, this will imply log x is less than log e. For monotonically increasing functions, as x increases, log x also increases. That is, the trend is maintained. And when x is greater than e, that is from e to infinity, log of x will be greater than log e, and log e is equal to 1, and this is equal to 1. So log x is less than 1 in this interval, and log x is greater than 1 in this interval, and therefore 1 minus log x will be greater than 0. 1 minus log x will be greater than 0, because log x is less than 1. Log x is less than 1, therefore 1 minus log x will be positive. And in this, 1 minus log x, will take this to the other side, 1 minus log x is less than 0. Log x is greater than 1, log x is greater than 1, 1 minus a thing greater than 1 will be negative. So this will be negative. So we enter the following conclusion. In 0 to e, that is in this interval, 1 minus log x is greater than 0. And e to infinity, that is x is greater than e. 1 minus log x is negative. This is negative. So we can say fx is monotonically increasing in this interval, and in this interval fx is monotonically decreasing, and therefore we can write fx is monotonically increasing in 0 to E, and fx is monotonically decreasing in e to infinity, and this function is not continuous at x equal to 0. 0 is also not in the domain of this function. So we cannot change this bracket into a square bracket. So we leave the result here. Now we consider the second part of the question. Here fx is log 1 plus x minus 2x over 2 plus x. And we have to find the interval of increase and decrease of this function. In this question also, there is no interval given. So we will first find the domain of this function. Now domain of log of 1 plus x. Log of 1 plus x. So 1 plus x should be greater than 0. That is, x is greater than minus 1. That is minus 1 to infinity. This is the domain of this function. And in the domain of this function is whole real line except the point x equal to minus 2. So domain of this function is r minus 2 and intersection of these two. Now minus 2 is not included in this. So domain of f will be minus 1 to infinity. If minus 2 would have been in this interval, we would have rejected it. We would have deleted it. So domain now is minus 1 to infinity. Domain of f is minus 1 to infinity. Now we find f dash x. F dash x is differential of log x is 1 by x. So differential of log 1 plus x is 1 over 1 plus x into differential of inner function is 1 minus, here we will use quotient rule. Gx whole square gx into f dash x. 2 I am taking common. 2 I am taking common. So this is gx square gx into f dash x. Fx is x. So differential is 1 minus x into fx into differential of this is 1. So we get 1 upon 1 plus x minus this x cancels with this, and we are left with 2 2's are 4 over 2 plus x whole square. 4 over 2 plus x whole square. Take the LCM. This is 1 plus x into 2 plus x whole square. So LCM we have taken 2 plus x whole square minus 4 into 1 plus x. This is equal to, open this bracket, a square plus b square plus 2ab, that is 4x minus 4 minus 4x whole divided by 1 plus x into 2 plus x whole square. Now this 4x cancels with 4x, 4 cancels with 4, and we are left with x square over this. This is equal to x square over 2 plus x whole square into 1 over 1 plus x. Now this is positive definite. This is positive definite. Therefore sign of f dash x will depend only on this term. So we must take 1 plus x is equal to 0. This implies x is equal to minus 1. And f dash x is also 0 at x equal to 0. So we must give a due consideration to this point also, where f dash x is 0 and where it is undefined. This is positive definite, sign will not depend upon this. So we will have this and x equal to 0. So we will have domain is -1 to infinity. Now this point is x equal to -1. So this is the end point of this interval. And x equal to 0 is here. So we will say f dash x is greater than 0, because if this is positive, f dash x will be positive. So f dash x is greater than 0 in -1 to infinity -0. We must exclude this point. This point 0 must be excluded, because f dash x is 0 at x equal to 0. F dash x is 0 at x equal to 0. So fx is monotonically increasing in -1 to infinity -0. And since fx is continuous in -1 to infinity, including the point x equal to 0, therefore fx is monotonically increasing in -1 to infinity. This point can be included. Fx is strictly monotonically increasing in this interval, and it is monotonically increasing in this. If you want to find strictly monotonically increasing, then it will be -1 to infinity -0, because f dash x cannot be 0 for strictly monotonically increasing function. But for monotonically increasing function, it can be 0 at a finite number of points where the function is continuous.